Okay, this is a continuation of lesson 1.3, solving equations with variables on both sides. Today is day 2. We will be working with examples 3 and 4 out of your textbook. Some equations do not have just one solution. Equations can also have no solution or infinitely many solutions. So this is kind of a new concept for you. So previously we had worked with just equations that you solve for x and get a solution. So when solving an equation that has no solution, you're going to obtain an equivalent equation that is not true. Here's the most important part. Not true for any value of the variable, such as 0 equals 2 or anything that is not equal to each other. So let's look at an example in your book. Example 3 shows 3 minus 4x is equal to negative 7 minus 4x. So you've written the equation. Now you're going to use the addition property of equality to get the variables on one side. So you add 4x to undo the subtraction to both sides, but note what happens here. It cancels on this side and it cancels on this side, because on both sides negative 4 plus 4 is 0. You are left with an expression that simplifies to 3 is equal to negative 7, and this is never true. So because it's never true, we would say this has no solution. Okay, let's look at the next scenario. When solving an equation that has infinitely many solutions, you will obtain an equivalent equation that is true for all values of the variables, such as negative 5 equals negative 5. So it's kind of like seeing an identity property. It's the same thing on both sides. And for some reason, some of my equal signs didn't copy very well when I copied them. So this is actually 4 equals 4. I don't know why that does that. But anyway, let's look at the problem. 6x plus 4 is equal to 4 times the quantity, 3 over 2x plus 1. After doing the distributive property, note that at this stage you get something that looks very similar. 6x plus 4 equals 6x plus 4. But go ahead and use the subtraction property of equality to undo addition. So we'll subtract 6x on both sides. And then we get 4 equals 4, which is always true. So we have infinitely many solutions is our answer. Let's try some. The first equation, again, this is an equal sign right here and right here. Not sure why it's not copying. All right, 2x plus 1 is equal to 2x minus 1. So the first thing I'm going to do is try to move the variable. So minus 2x on both sides. The variable term cancels on this side, it cancels on this side. I get 1 is equal to negative 1, which is never true, right? So since it is never true, I would write no solution. Okay. How about here on number 5? We will distribute first. So half of 6t is 3t. Half of a negative 4 is a negative 2. And that's equal to 3t minus 2. You should see that it is the same thing on both sides, but let's continue with our problem solving. 3 minus 3 and 3 minus 3 cancels. Negative 2 equals negative 2. This is true all of the time. So we write infinitely many solutions. Let's try a couple more. In 6, we're distributing a third. So 1/3 times 2b is going to be 2/3, 2 over 3b, and 1/3 of 9 is 3, so it could be 9/3 or divide by 3. That's equal to, distribute over here to both, 2/3 b. Now you take 2 times 9 is 18, 3 times 2 is 6, 18 divided by 6 is 3, or you can cross cancel. So 2/3 b plus 3 is equal to 2/3 b plus 3. I can go through the process of, subtracting 2/3 b on both sides. All right, this one cancels. I'm left with 3 is equal to 3, which is always true, so I write infinitely many solutions. Okay, right here. So 6 times 5 is 30. 6 times negative 2v is a negative 12v. Negative 4 times 3 is a negative 12v. And negative 4 plus 1 is negative 4. So if I add 12v to both sides to use inverse operations, I get 30 is equal to negative 4, which is never true, so no solution. Okay? Make sure I spell that right. Okay. So today what we've done is looked at 2 different scenarios when solving. Now remember, just like yesterday, some of your homework problems may contain one solution. So solve it just like you would. Don't expect everything you do tonight to just cancel out and be either infinitely many or no solution. You could still solve for x is equal to something. And remember, if x is equal to 0, that's definitely one solution.